Okay, we're going to do a real simple example. Now, there is a bit of technology that people did not have the ability to understand in the 1910s, 1920s, and even later. And this technology is now, by definition, every one of you is aware of so much of it right now, just because you're exposed to it enough, that you actually know how to quantify the danger of it, most of the time. I'm going to give you an explanation of an exposure to something that sounds really terrifying if you don't know what it is. And I'll tell you what it is, and you'll be like, oh, okay. And then the light bulb will come on in your head. I'm going to hit you with a form of energy that can kill you, or save you, or do nothing of any kind to you. And the only thing I'm going to tell you is how often per minute or per second that I'm going to hit you with this form of energy. In counts per minute, counts per second, counts per hour, whatever. And I'm going to tell you that I'm going to use a standard for this that's considered safe and background radiation level, and it has a value of 60 counts per second, in that range. And that the background counts per second is 0. It is. So it's infinitely higher than 0. But there is one natural occurrence of it. But the natural background exposure, that's effectively 0, but it could be 1 count in your entire life, will definitely kill you. And another source that is 1 continuous exposure, not a count per second or count per hour, but is just simply continually exposed to you, may or may not kill you, depending on something else we haven't discussed. It's called electricity. That 1 count per lifespan is a lightning bolt. The continuous one is a 1.5 volt battery, and the 60 and 50 cycles per second is the standard amount of electrical tickle you get if you could sense the 1 picoamp that goes through your body every time you plug that USB charger in, because it does actually expose you to that. It does. Even though it's 120 volts and it's trying to go over a distance of air and whatever, you're technically exposed to an incredibly low amperage, 60 times a second. How often per second, it doesn't matter, or per hour. It's the voltage and how much current goes through you. Most of you are instantly able to evaluate this and realize that the number of times per second or per hour or per day is not relevant in any way, because it's a bullshit thing if you don't know, well, how intense is it? But if I say radiation and Geiger counter that only counts how often per minute or per second that you're hit with a blast of some sort of energy, you will immediately glaze over and not realize, oh, how much goes through you? How intense was it when it first hit you? Is it something that can get below the skin? Alpha, beta, and gamma radiation obviously have different depths, but gamma, beta, alpha, and other radiations are not quantified based on how much damage it does to you. It's whether or not it's a raw count. This is the equivalent to saying, but it's the frequency of the Wi-Fi that causes cancer, not whether or not it's above a certain milliwatt rating, right? Hey, it doesn't matter what the context is. Every joke that mentions Nazis or any video vilifying them must be Nazi. This is called the polydimensional issue. How do we rate the amount of energy a person is hit with that it causes damage? When it comes to electricity, it's usually how much energy it takes to harm you, and it's a certain number of milliamps. But that's hard to quantify. It can also be wattage, but that just determines how much energy is expended in you. You could be hit with something potentially that have 1,000 watts and not go through you. It's literally based on how many milliamps goes through. Oh, and yes, there is a frequency thing. There are cycles per second ratings that can cause this. The only thing worse than that is actually running DC, 0 cycles per second, because it'll kill you dead on a doorknob at 50 volts, depending on conductivity. And depending on whether or not you have a heart defect. I happen to have 1 or 2 probably at this point. I'm scared to actually go to the doctor and have them evaluate the other things. The reason I'm bringing this up is radiation counts out of a Geiger counter count how many times per minute or per second or per hour it detects any kind of radiation at any level. It uses an avalanche function. I'm going to describe in a minute. But basically, if anything goes through a gap in a specific volume of space that's used to detect it, anything goes through there, it counts it as an impact. It doesn't care if it's an incredibly high intensity or low. Well, actually it does. If you get hit with an extreme intensity level, it may not even count it. Or it may be overwhelmed by the next weak signal. Or it may completely incapacitate its ability to detect any more of it. See, the complexities and facts about the subject get in the way of you being able to look at some radiation map somewhere and not say, so, what's the amps and volts on that? People who talk about the dangers of radio signals ignore the wattage, the literal energy output that could do a damn thing to you. No, it's the resonant frequency. Okay, well, sunlight's at a much higher frequency and it puts out trillions of watts of energy that hits the Earth. But you're not worried about global warming. So let's get this done. Normal background radiation is typically in the range of 25 to 75 counts per minute. You'll see that everywhere. Let's just say it's 88 because that's the highest rating I found as being a normal background radiation. That counts per minute. Okay, immediately, unless you're desperately trying to say Fukushima is a terrible thing, or I believes in radiation maps, or unless you're insisting on saying, well, that doesn't matter, we just need to know it, that we're supposed to be scared of it. The first thing out of your mouth should be, how the hell are they measuring it? A specific volume of space is tested by filling it with a gas and having it react violently to any event. You can lower or increase the intensity reaction to it. Its sensitivity can be altered. But you have to know how much it was altered or if it could be altered. You have to know the make, model, and brand of the piece of equipment that's doing the evaluation. You have to find out whether or not it's trying to level out the numbers or just give you raw counts. And most importantly, you need to find out if it's been calibrated based on exposure. And is it a narrow angle where it's only looking in one direction, like a feed horn on a microwave antenna on top of a building over there? Or is it just a little pin-up antenna sticking up like that? There are radiation detectors that can detect radiation from every angle. Or do you aim it at a specific source? Is it a focus? Is it like using a set of glasses or a lens or camera? Or is it just using a light detector? A camera isn't the same thing as a light meter. So suddenly you have to know all the details, otherwise it's bullshit. You can make it have any count rating you want. And you know what's funny? Obviously, if you just increase the volume of it, or the size or surface area, or orientation, you can get a higher count rating. You can get any count rating you want. And if you throw lead over it, you might get 0. Specific brand, model, specific orientation, height above ground, calibration methods, whether or not it has bias set, whether or not it was set against or compared to the count of background. It only means something if it's an increase, or maybe even a decrease compared to background radiation. Does it do the plot based on decades of data collected in the same area? Does it give you a wraparound view on Google Street View of what's nearby? You can't complain about temperature meters being on black tar roofs for measuring global warming, or being right next to air conditioner or heating systems or vents. You are not allowed to complain about that if you don't double check whether or not your sources, all 3,000 of them they claim all over the United States, are done under conditions you would consider sane. Most weather stations do the same arrangement of hardware every freaking time, so they're incredibly consistent. And if they're not consistent, they're not worth it. Counts per minute CPM rate of ionization events per minute detected inside of a piece of equipment with specific characteristics of volume, total volume, what type of gas, what type of reaction curve, does it react more or less to certain things, what's its minimum cutoff to react, what's its saturation level where it becomes useless when you're being hit with literally a nuclear blast, and where was it pointed if it could be aimed. 1 Becquerel is equal to 1 disintegration per second at the radiation source. You could almost use it that way. 60 disintegrations per minute. That's 1 Becquerel. All right? So, if you're seeing 200 disintegrations per minute, that's 3 times, that's like 3 Becquerels exposure, right? Or is it? Monitoring stations are broadcasting the raw radiation count from Geiger counters. Why would you use a Geiger counter to measure how much exposure and damage a person would experience? Because they make clicking noises like in the movies. That's one reason. The other one is, well, everybody knows what a Geiger counter is. And the next thing is, they're fungible. Depending on which way you position them, they're going to give you no count or every count. And if you see constantly that the area always has 300 counts per minute, That means that's background level, because by definition background radiation level is whatever you detect all the time when there's nothing going on. Do they show you a graph of any changes for that thing, or on average all over the planet? What's the average radiation count using all these meters? Is it all over the place? Do they acknowledge on the page tacitly that this is a waste of your time? Geiger counters measure counts but not energy level or of the radiation. They do it by amplifying any event. It's not an energy level or rank or type. It doesn't tell you whether it's alpha, beta, or gamma, or any other. No discrimination between radiation types is provided for any of the particle types. They can't measure the incident radiation energy. They don't tell you how intense it is. There's no voltage to this cycles per second. It's not relevant. And they're unable to measure extreme rates without any errors. They can just peg and not work anymore. There's an exhaustion function apparently. But I don't know. I'm going to be corrected by people, and I'm requesting that Forbid TV correct me on this and do a video explaining this in an analogy you and I can use. For instance, counts per minute. Okay, firing rate for bullets. If I shoot you with a pellet gun loaded with 0.01 millimeter bullets, that's a little bit bigger than a human hair, and they're going Mach 1, and you're wearing a sheet of paper, will they get through? Okay, now I hit you with 150 caliber going half the speed of sound. Which one is worse? Yeah, the counts per minute isn't relevant. These are subatomic particles. You need to know how much energy they carry. That requires that you actually measure just simply the energy level output. Count rates don't equate to dose rate unless you calibrate them for the area itself and use the damn chart on the back. And then you should just be publishing a dose rate. There is no simple universal conversion factor. They are instrument specific, and they don't give the same result in the same room for different meters, and sometimes for the same meter, depending on orientation and positioning and everything else. If you position them to get the maximum readout, you may be aiming it at the dirt, which has more radiation sources in it, like uranium or radon. If you aim it towards the sky, you're going to get cosmic radiation behavior during the day or night, depending. If you aim it at the sunset or sunrise, do I have to keep going? If you aim it south, you'll get, well, then that'll be polarized by magnetic fields. How do you measure these things? Or you could just air filter and see if you're getting radioactive fallout. Oh yeah, that would be a completely different methodology and wouldn't be useful with a Geiger counter. So what are these things measuring? Are they all exactly the same? Yes, I like citizen scientists too. But a citizen scientist wouldn't tell you, well, the power source was 60 cycles a second. Okay, was it 60 cycles a second hum in headphones? Or is it a power line at 10,000 volts? Or was it an electrostatic generator playing, you know, the Star Wars theme for entertainment value on a desktop Tesla coil? It's meaningless unless you have that data. Any conversion is impossible unless one modifies the tube's characteristics or the count data for specific thresholds, so each count result in a particular radiation type is equivalent to a specific dosage. This technique is known as energy compensation. The detector tube is used to produce a dose reading biased by sensitivity and expressed in counts per minute divided by millirems per hour. Asking how many barricles or counts per minute is normal for background radiation is like asking how bright a light bulb is by measuring its voltage. That's not relevant. You can have a car headlight that's at 12 volts and a lot brighter. It's not an absolute measure of the strength of the source of radiation. It could be weak and irrelevant, but very common, or deadly in one damn giant click. Geiger counters are the blurry UFO photos for radiation scaremongering. See links below. Thanks for watching, and you can watch some kids do experiments like this and come to the same conclusion. If a 10-year-old kid can figure this out, why can't radnets? And why don't Fukushima fearmongers acknowledge this? How many hertz is it for you? Show me where it hurt.